is the first question of part 2 on the January 2017 Common Core Algebra 1 Regents. Altogether, it is question number 25. And the question reads, in attempting to solve the system of equations y equals 3x minus 2 and 6x minus 2y equals 4, John graphed the two equations on his graphing calculator. Because he only saw one line, John wrote that the answer to the system is the empty set. Is he correct? Explain your answer. So let's talk a little bit about solving the system of equations. A system of equations is two equations with two variables or more. You could also have 3 and 3, but Algebra 1 does not cover those as far as we recall. So here we have two equations with two variables, and the two variables are y and x. And on a graph, the solutions are the intersection points. That is where both x and y are the same for both equations. That's how we would produce an intersection point. Now, if we are to graph these two, we would indeed get one line. Let's take a look at y. So our first equation is already in the form y equals mx plus b, so let's get the second one into that same form. I would subtract 6x from both sides, divide everything by -2. What we get is y is equal to 3x minus 2. And of course, you should now notice that these two are exactly the same line, so it's not awfully surprising that when we put these in the graphing calculator, we'd only see one line. Now, because they are the same line, it would sort of be like graphing the same line twice. So 3x minus 2, we'd start at -2, and we'd go up 3 points and over 1. It would look something like that. And if we graph the second line, we'd literally graph the same exact line on top of it. So the question then becomes, how many points of intersection are there? And the answer is infinitely many. Each point, of which there are infinitely many, that lies on the first line would also lie on the second line because, well, they are the same line. And we could test that theory by substituting in 1 for x. When we substitute in 1 for x, we would get 3 times 1, which is 3, minus 2, which is 1. And that kind of falls in line with what we have here. The point is 1, 1. Well, if we do that for this equation, naturally, because the equations are the same, we get the same exact point. So the solution is not the empty set. It's actually infinitely many points as long as they follow the first equation, which is also the second equation. Since they are the same equation, there are infinitely many solutions. Because as long as a point satisfies the first equation, it would satisfy both equations. So in short, no, John is not correct. The solution is not the empty set. The solution is all the points that satisfy the first equation.